How's it going again? So basically, what I showed you today is how to solve a square root equation. And by the way, I accidentally used the word quadratic later on. I apologize. I'm sometimes get my words mixed up, but I'm talking about square root functions or equations, so that we know. Okay. So a couple of things. Just I'm going to show you three scenarios and then work through them. First thing we want to do is always you want to isolate your radical if possible, and I'm going to show you a scenario where that's not going to work. We want to power up, and what I mean by power up is, if we're dealing with square roots, like in this case, we want to square both sides. If we're dealing with cubic roots, we cube it, and so on and so forth. We're going to solve it, obviously, and then finally we're going to check extraneous values to make sure that they work or they don't work. Do we have a no solution? Only one solution works, things of that nature. So one thing I'm going to tell you is this: square root of x is equivalent to the x to the 1/2 power. I'm going to stick with square root of x, but know that if you see x to the 1/2 power, we're basically talking about the same thing here. Okay, it's just one's exponential value versus a radical here. So that's kind of the difference. First scenario is you have a radical square root equation set to a constant value, and it's pretty straightforward. You just want to make sure that you isolate your radical sign first before you do anything else. And then from that point on, solve it. Isolated radical. So we're going to power up by 2 or by squaring it, since we're dealing with square roots. And the reason why is because square and square root are the inverses of each other. So squaring the square root actually cancels out or becomes 1, however you want to say it. And then this becomes 4. Subtract your 1. So in fact, we get that x is equal to 3. And then we check it by subbing it back in. And when you work through this, what you get is the fact that 6 is equal to 6, which checks out. And that's your solution that you have there. Okay. That's pretty straightforward, standard in terms of solving a square root. Isolate, power up, solve it, check it. Okay. And then we come to something that looks like this. And I can hear people saying, oh my God, there's 2 radicals on both sides. So what? That's okay. All that means is that we can't isolate radicals because we have 2 of them. So we're going to skip to the second part and just basically say we're going to power this thing up by, again, in this case, squaring it because we're dealing with square roots at this moment. Radical square canceled out. That becomes x plus 7 on one side. Here, this square has to make sure you apply to the square root, the radical sign, and the 2 coefficient in front. And what basically happens is you end up with 4, and you end up with 2x plus 5. And then at this point, you can go ahead and solve through, which I'm going to just do it minus x, 7x, minus 20, divided by 7, so that x is equal to negative 13 over 7. Now, I know some of you are going to want to throw this in the calculator and get a decimal answer. And if you did that, you would get negative 1.857,143. And yes, I already did this so that you know. So that's how I know that's the value. And you're going to want to stick with this number. But here's the thing I'm going to tell you. When you check an extraneous value, the one thing you want to make sure you do is use fractions. They're more accurate, and when you actually check the extraneous, you're going to get a better, you're going to see it better in terms of whether it's a true solution or not. If I use this value, you're not going to get something that works perfectly. And so if I take, I'm going to show you what I mean by that. So if I take this fraction and I plug it in to check it to see if it works or not, if I do 2 square root of 2 times negative 13 divided by 7 plus 5, and I get 2.267778683. Okay. If I take the other side and do the square root of negative 13 divided by 7 plus 7, I get the exact same thing. That's nice. That's what we want. Okay. We want to make sure that this is going to work and it's going to work almost perfectly. If I use the irrational number instead, that rounded decimal value, this one right here, you're not going to get this. And so the question always becomes, well, is it true? Is it close enough? We don't want it to be close enough. We want to get it as close as most exact as possible. So using fractions is going to be the best way to go about doing this, because this is what you want to see. What this tells me is that this solution of negative 13 over 7 is a true solution. What it also tells me when I do this, so that you know, is essentially that the y value for the x coordinate is going to be this right here. And what that means is if I were to graph this, it would look something like this. The solution here has an x and a y value. Here's your x. Your y is going to be this value right here. Okay, so that's what we're looking for. So make sure you use fractions, bottom line. Last scenario looks something like this. Now, it doesn't look too bad when you kind of throw it, but then you notice what you have is a square root set to a binomial value. And we're going to follow the same rules in terms of isolation. Nothing to isolate, we're good there. We're going to power up. And when we power up, okay, square root goes away. But now you have this guy right here. Well, some of you are going to be tempted to go, oh, it's x squared plus 1. Please don't do that, okay? X squared 1, no. This is basically an expansion. And what this indicates is the fact that we have two factors of x plus 1, which means it looks something like this instead. Okay? And what does that mean? Oh, it means we're going to multiply two binomial factors. And most of you probably know that method as FOIL method. Okay? So we're going to do that. X squared plus 2x plus 1, okay, is equal to 7x plus 15. One thing you kind of remember is if you square a binomial, you're going to end up with a trinomial. Okay, kind of the general rule. Well, since I'm in quadratics, guess what that means? Our old friend quadratic formula or factoring, depending on how you want to approach it. Which means I have to set everything to 0. In this case, it looks factorable, and it looks like it's going to be x minus 7, x plus 2. Of course, we don't want these factors. What we want are the actual solutions. Because now I have two possible x values. Well, how do you know which ones actually work? Check it. That's the last step to this. So if I take these, I go back to my original equation. There's the bell. 7 plus 1 is equal to 7 times 7 plus 15. What you get is the fact that 8 is equal to 8. Checks out. That's a solution. If I do negative 2 plus 1 is equal to the square root of 2 times negative 2. I'm sorry. Let me erase that. I messed that up. 7 times negative 2 plus 15. What you get is negative 1 is equal to 1. We reject that because it's not a true statement. Therefore, this is what we call an extraneous solution, which means it doesn't fit. Here's your linear line. Here's your square root. There's only one intersection point, and it happens to be x, where x is 7, and in this case, y is 8. So this one actually doesn't work. All right. See you later.